Hello, everyone. This is Mr. Hilko. I'm going to take you through our next coordinate proof, which is found on page 33 in your unit packet. And the proof will be proving that a quadrilateral is a rhombus. Okay? So first, to develop our game plan. Some of you might have this sheet, or I can post it on Google Classroom. But for this proof, we have a few different options. Okay. The first thing we want to do in each case is show that the quadrilateral is a parallelogram, and we're going to do that by finding the slopes of all four sides. And then after we do that, to show that the parallelogram is a rhombus, we have a couple different options, okay? Remember, one of the key properties of a rhombus is that the diagonals are perpendicular, so that would be one way to show it's a rhombus, and I think that's the easier, quicker way because it involves slope. Or another way, this one's more obvious when you think of the rhombus, but it does take a little bit longer, is to show that all four sides are congruent. So you'd have to use the distance formula 4 times and calculate the length of each side. Okay, but we're going to go with that first option. Okay, so the first thing we're going to do is show that it's a parallelogram by calculating the slope of each side. So the sides I would need to calculate the slope for are JK, joking, ML, KL, and JM. Okay, now the slope of JK would be, and since it's already plotted, we're gonna count rise over 1. It would be a rise of 1, 2, 3, and a run of 1, 2, 3, 4, which is a slope of 3/4. ML, also a rise of 3 and a run of 4, giving it a slope of 3/4. Since those slopes are the same, we know that JK is parallel to ML. As far as KL and JM, they're actually both horizontal lines. So a horizontal line would actually have a slope of 0. There's actually no steepness to those lines, and slope is a measure of steepness. But you actually could still use rise over run, because it would be a rise of 0 and a run of 5, which would be 0 over 5, which is 0. Okay? But in the end, that shows that KL is parallel to JM. Since both sets of opposite sides run parallel, we now know that the quadrilateral is a parallelogram. Okay. Now remember, you have the two options, but we're going to choose the path of least resistance and use option number 1, showing that the diagonals are perpendicular. Okay. So focusing on your diagonals, you are going to consider segment JL and segment KM. To show they're perpendicular, we want to find the slope of each diagonal, and hopefully they come out to be negative reciprocals. And if they are, then those diagonals would be perpendicular. So JL, starting at J, is a rise of 1, 2, 3, followed by a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be 3/9, which reduces to 1/3. KM, starting at K, since it's farther to the left, I'm going to be going down 3, forward 1, negative 3 over 1, which is a negative reciprocal with the 1/3. So perfect. So what we just showed there was JL is perpendicular to KM. Okay, so I had my game plan. I showed my calculations. The final thing I want to do to put the finishing touches on is come up with a concluding statement. Okay, so what I'm going to say is that quadrilateral JKLM is a parallelogram, which I showed here with my first 4 slope calculations. whose diagonals are perpendicular, which I showed here with my final two calculations. Therefore, quadrilateral JKLM is a rhombus. Okay, so that completes our proof showing that quadrilateral JKLM was a rhombus. Thanks for joining. Talk to you guys soon. Bye-bye.